Hello, today we're going to do another significance test. This one says, according to the National Institute for Occupational Safety and Health, job stress poses a major threat to the health of workers. A national survey of restaurant employees found that 75% said that work stress had a negative impact on their personal life. So a random sample of 100 employees from a large restaurant chain finds that 68% answer is yes when asked that same question. It's a statistical evidence that this is different than the national average. Now, one key thing to look at is the word different. Uh, we're not wanting to see that this is less than, more than, just that it's different. So that'll help us out with our hypotheses. Our null hypothesis is that our population proportion is the same as the national proportion, which is 0.75. Our alternative hypothesis is that it's different than that, which is not equal to 0.75. Now, P isn't the national, because we know the national is 0.75, so we don't need to test that. P is the proportion of people at that restaurant chain that feel like stress had a negative impact on their life. So it is the all right. So it's the proportion of workers at the restaurant that feel that at that chain that feel that stress negatively impacts their personal life. Conditions are out of the way. We got a point for that, point for that, point for that. Good. Now we want to check the conditions of our hypotheses. First, does data come from a random sample? Looks like it comes from a random sample. So you say something about how data come from a random sample. Then we need to check independence. 100 people, employees from the restaurant, so 10 times that is 1,000. Now we don't know how big this restaurant is, so we're just going to have to assume the restaurant chain has more than 1,000 people for independence. For independence. All right, so now we just have to check normality. Now, in this case, it looks like we have two proportions. So when we have proportions, we're going to want to we want to check that n times p. So 100 times 75%, that's 75. So 75 is greater than 10. So that means 25 is greater than 10. So we can use a normal approximation. All right. Now our conditions are done. Now we just have to do the calculations. So now we have to look. We're looking at the probability that our p hat is going to be less than 0.68 because that's our thing. And then we're going to multiply that times 2 because this is a two-sided test. So we're going to take 2 times the probability that we get a z-score less than or equal to 0.68 minus our mean of 0.75 all over our standard deviation, 0.75 times 0.25 over n, which was 100, and then square root that. So now I got a z-score of negative 1.616, so negative 1.62. So if I take my normal CDF from negative infinity up until that number, I have 2 times 0.053. So if I multiply that by 2, I get a p-value of 0.1059, so 0.106, about 11%. So now let's interpret this. So since the p-value is greater than our alpha level, alpha, they didn't say alpha level, so let's just assume 0.05, we can fail to reject null. And so from that, we don't have evidence that the chain is different from the national. All right, there's a significance test.